we students from second year aeronautical department, we are going to present a small video presentation on topics heat transfer, specific heat and latent heat. So let's start. Uh, so first is heat transfer. So what is heat transfer? So according to thermodynamic system, heat transfer is defined as the movement of heat across the border of the system due to a difference in temperature between the system and its surrounding. So now basically heat transfer is discipline of thermal engineering that concerns the generation, use, conversion and exchange of thermal energy between physical systems. Heat transfer is classified into various mechanisms such as thermal conduction, thermal convection and thermal radiation and transfer of heat energy by phase changes. So now I will show you one image that most of the times heat is transferred from hot body to cold body. Now how heat is transferred? Heat can travel from one place to another in several ways. The different modes of heat transfers include conduction, convection, and radiation. So, we are going to see it in detail. So, meanwhile, if the temperature difference exists between the two systems, heat will find a way to transfer from higher to the lower system. So, as I have told, there are three modes of heat transfer: conduction, convection, and radiation. So, we will see these modes in detail. So let's start with conduction. So what is conduction? Conduction is defined as the process of transmission of energy from one particle of the medium to another with with the particle being in a direct contact with each other. So in another word, conduction is the transfer of energy from the more energetic to less energetic particles of a substance due to the interaction between the particles. So let's see the example. Ironing of cloth is an example of conduction of the heat is conducted from the iron to the cloths. So heat is transferred from the hands to ice cube, resulting in the melting of an ice cube when held in a hand. Heat conduction through the sand at the beaches. This can be experienced during the summers. Sand is a good conductor of heat. So you can see this animation. So next we will see convection. So what is convection? Convection is defined as the movement of fluid molecules from higher temperature region to lower temperature region. So example of convection, boiling of water, that is molecule that are denser move at the bottom while the molecules which are less dense move upward, resulting in a circular motion of the molecules so that water gets heated. Warm water around the equator moves towards the poles while cooler water at poles move toward the equator. Blood blood circulation is in a warm blooded animals takes place with the help of convection, thereby regulating the body temperature. So here also you can watch this animation for better understanding. So, radiant heat is present in some or other form in our daily lives. Thermal radiations are referred to as radiant heat. Thermal radiation is generated by the emission of electromagnetic waves. You can watch this animation for better understanding. So, now radiation examples. Microwave radiations emitted in the oven is an example of radiation. UV rays coming from the sun is an example of radiation. So the release of alpha particles during the decaying of uranium 238 into thorium 234 is an also example of radiation. So now we will see the application. Heat transfer is a critical part of many engineering and technology fields, including the automotive engineering, thermal management of electronic devices and systems, climate control, insulations, materials processing, chemical engineering, and power station engineering. So hello everyone. As you have seen, three modes of heat transfer. Now we are going to move to our next topic, that is specific heat. So basically, what is specific heat? Specific heat is the amount of heat energy required to raise the temperature of one unit of mass of substance by 1 degree Celsius or 1 Kelvin. It is the property that varies for different materials and it is denoted by symbol C. Now, to find the specific heat of any substance, we use this formula, that is Q is equals to mc delta T into Q, where Q is equals to heat energy, then M is the mass of the substance in kilograms, and C is the specific heat, and del T is equals to change in temperature. So now, I want to discuss some key points regarding specific heat. So, materials with high specific heat can absorb a lot of heat without a large temperature increase. Then, water has specific heat, that is approximately 4184 joule per kg degree Celsius. Then, meaning it can store heat effectively, which is why it is used in cooling systems. Then metals generally have low specific heat, so they heat up and cool down quickly. So now let's move towards our next topic, which is latent heat. So what is latent heat? Latent heat is the amount of heat absorbed or released by a substance during a phase change, such as melting, freezing, boiling, and condensation, without changing its temperature. It is associated with breaking or forming intermolecular bonds rather than changing the temperature. So basically, there are two types of latent heat, that are latent heat of fusion and latent heat of vaporization. So the heat required to change a substance from solid to liquid at its melting point, it is latent heat. So example of latent heat of fusion, it is melting of ice. It's a common example you may be knowing. So second is latent heat of vaporization. The heat required to change a substance from liquid to gas at its boiling point. So example for this is boiling water into steam. As we can see everywhere, this boiling water into steam in our daily life. So if we want to calculate the latent heat of any substance, then we can use the formula, that is Q is equals to ml, where Q is equals to heat energy, m is the mass of the substance, and L is the latent heat.
So this is all about heat transfer, specific heat and latent heat. For more information, like, share and subscribe.